Computers appear good at multitasking, but they actually go back and forth between executing instances of programs. This is called its process. When the computer goes back and forth, it's called context switching. In this illustration, the purple and green are congruent processes because if you draw a line from their start to finish, these lines overlap. The purple and blue are not congruent. Another thing to note is that an exception can interrupt a process.
Pay attention to me.
For example, the mouse keyboard fault or system call would interrupt it. There are some cases where they are doing multiple things at once. After they are split, they each have a separate copy of the variables. Otherwise, they would be fighting over them, and which process gets to them first would be unpredictable. Programs do unfortunate, surprising things as is, so there's no need to add to that. Each process has its own integer process ID and address space. They each have their own %rip and stack and register contents. Even though these processes are related, they don't share much. I imagine it would be difficult growing up in such an environment. The ancestor process can have multiple child processes, and these processes can have their own processes. The babies can be cute, but it can become a lot to keep track of.
The forking happens even when fork is called during an if statement, such as if fork equals 0, which will allow you to make a block of code that only the child follows. Wait tells the parent to wait until a child terminates. Wait PID allows you to be more specific. For example, you may say, wait PID, KPID, ampersand status, 0. The KPID is referring to the process ID of which child should be waited for. If it is -1, you are saying that you don't care which child it is, like in wait. Ampersand status can be null. This status is the same as the one argument that gets passed to wait. The third argument is the option. 0 will wait until the child is terminated, like in wait. Other arguments will change what behavior of the child is being waited for. Exec is a family of system calls that focuses in on an executable process. So, we take the old address space and stick in this new process. execve takes in 3 arguments, like in execve, path, to-do, environment.
The child process can become a zombie process. Unfortunately for this zombie, there is no cure. If a child's parent dies, the process 1, called the DIL, steps in and lovingly adopts them. The ancestor can never become a zombie. No matter how many processes the ancestor makes, good code will always leave him all alone.
While a process is a zombie, it still runs and takes up energy. So, the zombie child must be reaped through exit 0. If the child has the adoptive parent instead of its original parent and becomes a zombie, it is automatically reaped.
I don't know why a zombie isn't always reaped automatically, since they can't be cured. I suppose they needed it to be more complicated, because too many people were passing the class. These are files. Files are an abstraction we use for organization of our data. Memory that we want to stick around after a program runs can come in many different forms. Metadata is data about the data. The metadata about files would include what type of file they are. They could be a directory or a regular file. We also need to know where this information is located. Another important thing to know is permissions. This tells us who can read, write, or execute the program. An application program interface, or API, has to do with these permissions. Directories map names to vnodes, aka inodes, number. These vnodes are identified by an entry in an array index. The vnodes keep track of where all the blocks of your files are, the owner IDs, the permissions, and the time of the last update. Technically speaking, both text and binary files are chunks of memory made of 1s and 0s. However, when it's classified as a text file, these bytes are known to represent ASCII characters. and we go and lump everything else together. The application program is what makes these classifications. The operating system and kernel don't care. Files are organized like a tree where the root is represented by a slash. Every file has an absolute path to it. For example, c:/users/car/OneDrive/desktop/catpix/gehictac.pptx. As a side note, you should not name a file gehictac. It may seem tempting when you're in a hurry and you don't know what to name something, but trust me, you will regret it later. If you want to refer to something in your current directory, you could use /. For example, /bubbles files also have a relative path. Let's say you're in a directory CS315. Then the relative path to bubble would be //bunny/bubble. The double dot says to go back one directory, and then you do it again and into bunny, and there you will find bubble. To get from audio to real file, you would say //bunny/real folder/real file.
Open, surprisingly enough, opens a file and returns a handle. This handle is like a gateway into the file. For example, fd equals open milkshake.txt, ORDWR, where fd is the name of the handle and milkshake is the original file. ORDWR says you will be able to read and write to the file. ORDWR can be replaced with ORD only or OWR only to only read or only write, respectively. If this is successful, you can then do the other options. Read copies bytes from the file into the address space. Writes copies bytes from the address space into the file. There are many things you can tell me related to interacting with files. The metadata given by stat and fstat contain things like creation time, last modification time, size, location, owner, and permissions. These tables are data structures used for file sharing. Each process has its own descriptor table.
All mine.
Each of these descriptor tables has an entry in the file table. The file table must be shared by all processes. It contains a reference count, the current file position, and a pointer to an element in the vnode table. The vnode table is also shared by all the processes. It contains most of the information contained in the stat structure, such as the location of the data on disk. A parent and child must both close their descriptor tables before that element in the file and vnode tables are deleted.